So what we have learned is that the line spectrum is unique for an element. So if you know that if you find if you are observing line spectrum of particular element, it will be different from line spectrum of another element. So what scientists have assumed is that line spectrum is something related to the arrangement of electrons around the nucleus, because and what differentiates an element from another element is either the number of protons that, or neutrons that are in the nucleus, and the electrons that are revolving around it. So the scientists are assuming that there's nothing to do it is nothing to do with the nucleus in which the protons are inside, protons and neutrons inside. It's all about the electrons that is making the difference in the line spectrum. So somehow studying the line spectrum, we're able to identify an element. It is unique to it. In fact, how do we know that the sun contains not only hydrogen but it has helium? Is through studying the line spectrum, or spectrum that is being emitted or absorbed from the sun, right? So in that line, Niels Bohr has devised a model of hydrogen atom. How would be an hydrogen atom? It will be in advance, or it is more logical than what Rutherford has said through its alpha scattering experiment through Gauss foil. Although the term nucleus was determined by Rutherford, there were some faults in some drawbacks in the Rutherford's model, against which Bohr has proposed a model. So this is what we are going to study. We're going to study the Bohr's model of hydrogen atom. How does a hydrogen atom look like, and why it is stable, and why it is forming the line spectra that we are seeing or we are absorbing. So this will be so there are certain postulates that we call assumptions, which are based on the observations that we have made or the experiments that we have conducted. So these are the four postulates which later on will be used to design or to tell to describe how an hydrogen atom will be and why it is stable. So the four postulates of Bohr's model for hydrogen atoms are: number one is that the electron, when they move around the nucleus. It is quite sure that they are moving around the nucleus, and they move around the nucleus in a fixed ratio, in a fixed radius. It's not like they will move in any path. They will be moving in some fixed path of some fixed radius, and those are called orbits. And while moving in those orbits, they will have certain kind of fixed energy. So the energy and the radius of the electron while moving around the nucleus is fixed. It will have either this value or that value. It is quantized. So the term orbits and stationary states. Orbits, stationary states. That means as long as they are revolving in those permitted orbits, they are said to be in stationary states, and they will not emit any kind of radiation, although they are charged bodies that are moving around the nucleus. And but the second postulate says that it's not that they will always move in one fixed radius. They may move from one stationary state to another stationary state, or from one particular path to another particular path, or one particular orbit to another particular orbit. That means they will move from either lower energy state to higher energy state, or back, or from higher energy state towards the lower energy state. The electrons can move, and while moving so, they may either release energy or they may absorb energy in the form of electromagnetic radiation. So if they are moving from if they are in lower energy state, and energy is supplied to it, or it is heated, or it is being struck with electromagnetic radiation, it will move the higher energy state. The electron will move from lower energy state to the higher energy state, and they will move to higher energy state, which will have particular kind of energy. It will have particular radius, which will have fixed radius. And in reverse of it, if they are coming back from higher energy state, which has a particular radius and particular energy, a fixed radius or fixed energy, when it comes back to the lower state, it will revolve around in an fixed orbit, or in a fixed, and it will have fixed energy. It will release energy in the form of electromagnetic radiation, which may be or which may not be visible to the naked eyes. So electron can either move from lower to higher energy state, or back from higher to lower energy state, while doing so it might absorb energy or release energy, right? From lower to higher, it will absorb energy because it is in higher state, and from higher to lower, it will release energy. It will be in the form of electromagnetic radiation that for which we can calculate the frequency. The third postulate says that the frequency of, in doing so, when they move from lower to higher or higher to lower energy states, its frequency will be it will have fixed frequency. It will emit electromagnetic radiation of fixed frequency or fixed wavelength, and it will be equal to the change in energy, whatever energy is here and here, the change in energy divided by Planck's constant, or delta E by H, or delta is what? It's E2 minus E1. E1 will be the lower state, energy in the lower state, and E2 will be energy in the higher state. The difference in energy divided by Planck's constant, which is 6.626 into 10 to the power minus 36 minus 34 joules second. And this is known as Bohr's frequency rule. The fourth and final postulate or assumption by Bohr, which will be helpful in describing the hydrogen atom, why it's stable, and how the electrons are moving, is known as it describes the angular momentum. It says that the angular momentum when an electron is moving around the nucleus in a fixed radius or having fixed energy, its angular momentum is again quantized. It's not normal momentum, it's angular momentum. And the angular momentum is given by the mass of electron multiplied by velocity and the radius, right? MVR. Simply M and V is normal linear momentum that we studied in class 9 and 10, and multiplied by R, radius, is known as angular momentum. It will be equal to N into H by twice pi, and the value of N will be 1, 2, or 3, or 4, or 5, any integral value it will be. So that means what? No matter what, in which energy state, lower or higher, it is moving, its angular momentum cannot have any value. It may have value, but it will be multiple of h by twice pi. H n being 1, 2, or 3. And 1, if it is 1, that means h by twice pi. Its angular momentum be h by twice pi. Had it been in the second, it can be 2 into h by twice pi, or it can be 3 times h by twice pi. So it will always be the multiple of h by twice pi. The angular momentum of an electron revolving around a nucleus for an hydrogen atom, not for any other atom, for hydrogen atom, will be multiple of h by twice pi. That means it is quantized. The angular momentum cannot have any other value. It will have some fixed value, and that will be multiple of h by Planck's constant by twice pi. I hope it's clear.